Welcome back students. Now we are going to study about chemical properties of alkanes. In this we will study that what are the different kind of chemical reactions which are shown by alkanes. Basically alkanes undergo substitution reactions which include halogenation, nitration and sulfonation. Apart from them we will study about oxidation, which is basic reactions for which hydrocarbons are used. As I told you, hydrocarbons are the sources of energy and energy is produced by burning of hydrocarbons or combustion or oxidation. So we'll study about all these. Let's start. Chemical properties of alkanes. So now we are going to discuss about substitution reactions in alkanes. Okay, one or more hydrogen atoms of alkanes can be replaced by halogen, nitro groups and sulfuric acid groups. So let's discuss first of all about halogenation. Halogenation is the process in which one hydrogen of alkanes is replaced by a halogen. And halogenation of alkanes takes place in the presence of sunlight. And actually it is a chain reaction. For methane reacts with chlorine to form chloromethane, and the reaction does not stop here but it continues. Again, the compound chloromethane further reacts with chlorine to form dichloromethane, which further reacts with chlorine to form trichloromethane, and the reaction continues till tetrachloromethane is formed. Let's have a look at the mechanism of this reaction and let's find out that why does this happen. But first of all, the rate of reaction of alkanes with halogen is in this order. Fluorine is most reactive, then chlorine, then bromine and then iodide. And while the rate of replacement of the hydrogen of alkane is in the case of tertiary followed by secondary and then primary. Actually what happens that we have seen just order that fluorine is the most reactive, then bromine, then chlorine and then iodine, fluorine, then chlorine, then bromine. But actually the fluorination is too violent to be controlled. Fluorine is so reactive that the reaction of fluorine with alkanes is uncontrolled. While iodine is very slow, it is the least reactive, it is very slow and it is reversible in nature. So it can be carried out in the presence of oxidizing agents like HiO3 or HNO3 only. Okay, so now let's have a look at the mechanism for halogenation. And this reaction of halogenation of alkanes proceeds by a free radical mechanism. First step is chain initiation step, and what happens in this step that the chlorine which we have taken reacts with sunlight and homolytic cleavage of the bond takes place, because of which two chloride free radicals are generated, and this is the initiation step. This is where the reaction initiates. The next step is propagation step, that means how the reaction proceeds. What happens that this chlorine radical which is formed reacts with methane, let's say, and it abstracts a hydrogen from there to form HCl, and a methyl free radical is formed. Now this free radical again reacts with another molecule of chlorine and abstract a chloride from there to form CH3Cl, and Cl free radical is generated. This Cl free radical again reacts with CH3Cl, abstracts a hydrogen to form HCl, and again a CH2Cl free radical is generated. This CH2Cl free radical again reacts with a chlorine molecule to form CH2Cl2, and a chloride radical is generated. Again this chloride radical reacts with CH2Cl, abstracts a hydrogen to form HCl, and yes, CHCl2 is formed, and the reaction continues till the formation of CCl4. So this was the propagation step. Now the question comes, how does the reaction stop? This reaction can stop only when these free radicals gets used up and they are not free for the reaction. So this can terminate in one of these following ways, that this chloride free radical which are formed they encounter each other and they react to form chlorine. So they are used up, they are not available for the further reaction. Or the chloride free radical reacts with methyl free radical to form CH3Cl, or another way, two methyl radicals react with each other to form ethane. This chloride, this methyl free radical to form CH3. So these are the three ways in which this reaction can terminate. The next is nitration of alkanes, and nitration involves the replacement of hydrogen atom of alkane by NO2 group of and this nitration of alkane is made by heating vapors of alkane and HNO3 at about 400 degrees Celsius to give nitroalkanes, and that is why it is known as vapor phase nitration. And the reaction involved in this is like that. Let's say CH4, a methane, which is gas again in the vapor form, it is reacted with HNO3, which is again in gaseous or vapor form, at 400 degrees Celsius as mentioned above, and this results in formation of CH3, NO2 and a water molecule. So this is the vapor phase nitration. During nitration, carbon-carbon bond of alkanes are to be decomposed due to strong oxidizing nature of NO2 to produce all the possible nitroalkanes. As NO2 is a strong oxidizing agent, what happens that sometime carbon-carbon double bonds break up and all the possible products are formed like this. This is a propane molecule, it is reacting with HNO3. So what are the possible products formed? First is nitration will take place at the end to form CH3, CH2, CH2, NO2, which is this product. Another possibility is that this bond breaks and results in the formation of CH3, CH2, NO2, which is this product. Another possibility is that nitrogen first attacked at this position, it may NO2 attacked at this position to form first product, it may attack at this hydrogen also to form CH3, CH, CH3, NO2, which is this product. Another possibility is that this bond gets breaked and we get CH3, NO2, and this is this product. So all the NO2 groups comes at all the possible positions and simultaneously all the possible products are formed. NO2 may come at this position, it may come at this position, the product may be formed by breaking of this bond, or it may also be formed by breaking of this bond. So all the possible products are formed because NO2 is a very strong oxidizing reagent. Next is sulfonation of alkanes, and this involves replacement of hydrogen atom of alkane by SO3H group and it is called sulfonation. Now lower normal alkanes do not sulfonated, but higher normal alkanes show sulfonation reaction when they are heated with oleum, that means concentrated H2SO4 at 400 degrees Celsius. And this is the reaction. Let's say this is hexane, and when it is reacted with H2SO4, it results in the formation of replacement of one hydrogen with SO3H group and water is produced. Now the reactivity order of sulfonation is tertiary, then secondary, and then primary. Sulfonation of alkanes also follow free radical mechanism just like chlorination. Next reaction is isomerization of alkanes, that means formation of isomers. The process of conversion of aliphatic compounds into aromatic compounds is known as aromatization. Alkanes having 6 to 10 carbon atoms are converted into benzene, and it's homologous at high pressure and temperature in the presence of catalyst. So this means when alkanes containing more than 10 carbon atoms are heated under pressure and high temperature, they result in the formation of benzene or any other aromatic hydrocarbon. Just like this. This is C6H14 when it is reacted at 600 degrees Celsius, 15 atmospheric pressure, chromic acid and aluminium trioxide. It results in the formation of benzene. So this reaction is known as aromatization. Now dehydration of alkanes. Dehydration simply refers to, yes, it is actually not alkynes, it is alkanes. Dehydration of alkanes. Dehydration of alkanes results in the formation of alkene. Just like dehydrogenation of alkanes. Dehydrogenation means removal of hydrogen. When hydrogen would be removed from these, let's say this is a compound CH3, when hydrogen would be removed, it will result in the formation of, yes, alkene or maybe alkyne or so on. So alkanes are dehydrogenated on heating in the presence of catalyst to produce corresponding alkynes or alkenes. If we further dehydrogenate this, it will result in the formation of alkyne. So they are heating in the presence of suitable catalyst. Next is pyrolysis. Now pyrolysis is the process of decomposition of a compound on heating in the absence of air. Alkane vapors on passing through red hot thermal tube in the absence of air decompose to simpler hydrocarbon, and this product formed during cracking depends upon the nature of alkane, temperature, pressure and catalyst used. So there are two processes which are taking place. The one is pyrolysis. Pyrolysis is simple decomposition of compounds on heating in the absence of air. Another one we are saying cracking, which is basically done in the presence of, at high temperature in the presence of catalyst. So alkane vapors on passing through the red hot metal tube in presence of air decomposes to similar hydrocarbons. These two are almost similar reactions, and this depends on nature of alkane, which is being cracked, temperature, pressure and the catalyst. Just like this, when this propene is undergo cracking, it results in the formation of propane to propene, or it may also result in the formation of ethene. So cracking has an important role in petroleum industry. Higher alkanes are converted into lower ones by cracking. So it is an important process which is used in petroleum industry. Now next are oxidation reaction. As we know, the main function of hydrocarbons is to produce energy, and energy is related to combustion. So, and combustions are oxidation reactions. So there are two types of oxidation reaction actually. The first is complete oxidation, which is also known as combustion. So alkanes burn radially with non-luminous flame in the presence of air or oxygen to give CO2, water along with heat. Therefore alkanes are used as fuels. Just like this. This is the general formula which represents the combustion of alkanes. If this is the general formula of alkanes CnH2n plus 2, in that case number of oxygen molecule required will be 3n plus 1 by 2, and n molecules of CO2 would be formed with n plus 1 water molecule. Just you can see CH4 reacts with 2 molecules of oxygen to form 1 carbon dioxide and 2 water molecules. The second type of combustion is second type of oxidation is incomplete oxidation. Now, incomplete oxidation of alkanes in limited supply of air gives carbon black and carbon monoxide, which is a main reason for air pollution. CH4, when it is burned in limited supply of oxygen, results in the formation of carbon monoxide and also carbon black. Another type of oxidation is catalytic oxidation. Now, lower alkanes are easily converted to alcohol and aldehyde under controlled catalytic oxidation. This is the example of controlled catalytic oxidation. In this, in the presence of red hot copper and iron tubes at high pressure and temperature, methane is being converted into methanol. Similarly, when it is oxidized using a catalyst molybdenum trioxide, it results in the formation of aldehyde, and this can also ethane can be converted into ethanol. So this is the controlled catalytic oxidation. In the presence of specific catalyst, they result in the formation of specific compounds like alcohol, aldehyde, and ketones. Higher alkenes on oxidation in the presence of manganese acetate give fatty acids, just like this. Next is chemical oxidation. Now tertiary alkanes are oxidized to tertiary alcohols by KMnO4, which is a very strong oxidizing agent. So you can see here, this is a tertiary alkane and it is oxidized by KMnO4, potassium dichromate, to produce a tertiary alcohol. Now there is a solved problem. On reaction of chlorine with methane, it is carried out in sunlight. Now the question comes, why? We have just seen in very starting that chlorination of alkanes is done in the presence of sunlight. The question comes, why? What is the role of sunlight here? Yes, the first step was formation of free radicals, which was done by sunlight. So the role of sunlight is to break Cl2 molecules into free radicals. The thermal decomposition of alkanes in the absence of air is called, we have just seen, it is called pyrolysis. So pyrolysis is the process of thermal decomposition of alkanes in the absence of air. So now we are aware of the chemical reactions shown by alkanes, that is what type of chemical reactions do they undergo. They mainly show substitution reactions. So all the reactions which come under substitution reactions are important for exam point. Apart from that, oxidation reactions are also important, so you must undergo them carefully. In our next video, we will move to special type of isomerism which is shown by alkanes only, and that is known as conformations of alkanes. Keep watching.